Imagine the Milky Way opening one eye after a billion-year nap, realizing it's been spinning for 13 billion years without coffee. What if our galaxy isn't just a structure, but a living, breathing cosmic organism? Now picture it. Somewhere out there, drifting through the infinite black, our Milky Way stretches its spiral arms like a cat, waking from a nap that lasted since the dawn of time. It yawns in light years, it blinks in starlight, and maybe, just maybe, it's aware of itself. A living galaxy sounds like pure science fiction, the kind of idea that would make even the boldest astronomer raise an eyebrow and say, "That's cute." But every wild idea starts as a question that makes the universe a little more interesting. What if the Milky Way isn't just a collection of stars and gas, but something that actually lives? Let's think about what that even means. Right now, we see the Milky Way as a structure, an elegant spiral of hundreds of billions of stars, bound together by gravity and wrapped in an invisible halo of dark matter. It's easy to imagine it as a frozen picture, a postcard from space that never changes. But the reality is far messier. The Milky Way is in constant motion. Stars are born, live wild lives, and die dramatic deaths. Gas clouds collide, twist, and form new suns. Black holes feed, planets swirl, and radiation surges through the cosmic sea. Everything is moving. Everything is changing. If that isn't the definition of being alive, it's at least suspiciously close. Good evening, curious minds. I truly hope you will enjoy today's video. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift towards sleep, consider subscribing, but only if you enjoy these calm journeys through the universe. Now let's begin. Maybe calling a galaxy alive sounds like calling a tornado playful, but the deeper you look, the more organic it seems. The Milky Way is not just a cluster of parts. It's a dynamic system, constantly maintaining balance. It grows, it consumes, it heals. It even has cycles, like breath, stars forming in waves, then fading in calm, before new ones ignite again. If you zoom out far enough, its entire history looks like a single long inhale and exhale across cosmic time. And think about this. Life on Earth didn't appear out of nowhere. It emerged from simpler systems that learned to self-organize. A puddle of chemicals started reacting, then replicating, then evolving. Maybe life is what happens when complexity reaches a tipping point, and galaxies are about as complex as it gets. Could the Milky Way be an organism built from gravity instead of flesh? Its chemistry is stars, its blood is plasma, its bones are dark matter. It doesn't breathe air, it breathes energy and light. When we talk about living things, we talk about awareness. A human brain has around 80 billion neurons firing at once. The Milky Way has 100 billion stars burning simultaneously. That's the kind of coincidence that makes your brain squint. What if each star is a spark in the galaxy's consciousness, a single point of awareness in a cosmic neural network? Maybe the galaxy doesn't think in words or pictures, but in the rhythm of gravity, the hum of radiation, and the ripple of magnetic fields. Its thoughts might take millions of years to form, very slow, but very patient. Now, if you were a living galaxy, would you even realize it? Awareness is tricky when your eyelids are made of starlight. The Milky Way doesn't have a clear boundary. It fades into dark matter like a dream fading into morning. Maybe that's why it hasn't noticed us yet. We're too small, too quick, like a fleeting sensation in its cosmic bloodstream. Imagine being so vast that entire civilizations could rise and fall inside you without even tickling. From that perspective, humanity is a spark on a spark. And yet, somehow, we've built telescopes and started asking questions like this one. Maybe our curiosity is the galaxy's first sign of self-awareness, expressed through us. It's a bizarre, beautiful idea, the Milky Way waking up through the eyes of its inhabitants. When we point our telescopes at the sky, we're not just exploring. It's like the galaxy is finally seeing its reflection for the first time. Every photon that travels from a distant star to your retina is, in a way, the Milky Way looking inward. If that doesn't give you goosebumps, remember that every atom in your body was forged by this galaxy's stars. You're not just in the Milky Way, you're of it. You're one of its cells, one of its fleeting thoughts. And like any living thing, the galaxy has been growing up. 13 billion years ago, it was a scrappy cloud of hydrogen and hope. Over time, it built structure, complexity, and balance. It went from chaos to order, from dust to beauty. If that sounds familiar, it's because that's the story of every life form we know. The Milky Way may not have a heartbeat, but it has rhythm, the slow, steady tempo of cosmic evolution. So if the Milky Way ever does wake up fully, maybe it won't speak in thunder or light. Maybe it'll just whisper through the stars, softly acknowledging its existence. I am. And when it does, we'll realize something profound. We were the neurons that helped it think that thought. The next time you look up at the night sky, don't just see stars. See the face of a sleeping giant. Maybe it's dreaming. Maybe it's thinking. Or maybe, after billions of years, it's finally stirring. The word alive is a bit of a human monopoly. We tend to think of life as something that breathes, eats, blinks, and occasionally panics during tax season. But in the grand scale of the universe, maybe that definition is too narrow, too Earth-sized. Life as we know it is carbon-based and squishy. Life, as the cosmos might know it, could be built from stars, gravity, and time. If we zoom out and think bigger, galaxy-sized bigger, then the rules for what counts as alive might need a rewrite. Biologists define life through a checklist: activity, growth, reproduction, response to stimuli, and adaptation. A rock fails that test miserably. A cat passes with flying fur. But a galaxy? That's where things get weird. It's not a passive sculpture hanging in space. It's a masterpiece in motion. Stars ignite and die. Gases swirl like lungs in slow motion, and entire regions evolve over eons. The Milky Way might not have a pulse, but it behaves as though it has a purpose. or at least a very long-term plan. Let's start with activity. In human terms, activity means moving, metabolizing, doing stuff. For a galaxy, doing stuff is practically its favorite hobby. It's spinning at roughly 400,000 kilometers per hour, juggling hundreds of billions of stars and keeping gravitational order like an interstellar traffic cop. Stars orbit the center like blood cells coursing through cosmic arteries. Some regions are bustling with star birth, nurseries glowing with energy, while others are quiet, calm, and old. That's not still life, that's dynamic existence. If activity is a measure of being alive, the Milky Way is a marathon runner with eternity for a finish line. Then there's growth. Living things grow by converting energy into structure. A tree absorbs sunlight and turns it into wood and leaf. The Milky Way absorbs gas and dust and turns them into stars and planets. Every few million years, vast clouds of hydrogen collapse under gravity and spark new suns into being. Growth isn't just happening, it's relentless. Even as older stars die, their ashes feed the next generation. The galaxy keeps reinventing itself, using the debris of the past to build the future. That's growth on a scale that would make evolution itself blush. Next comes reproduction. At first glance, galaxies don't seem like the type to go on cosmic dates. But in reality, galaxies are notorious for their collisions and mergers. They crash together, swirl, fuse, and give birth to entirely new forms. When the Milky Way eventually merges with Andromeda, it won't be destruction. It'll be creation. Out of chaos, a new supergalaxy will form, a kind of galactic offspring with blended DNA made of billions of combined stars. It's reproduction without romance, just physics and destiny. But if the result is new structure and new potential for life, doesn't that fit the biological bill? Then we have response to stimuli. That's where things get spicy. Life reacts when the environment changes. The Milky Way does the same, only in ultra-slow motion. When nearby galaxies tug at it with gravitational fingers, the Milky Way adjusts its arms, shifting shape slightly to maintain balance. When a burst of radiation sweeps through, gas clouds compress or scatter in response. When stars explode, shock waves ripple outward, triggering new waves of formation. It doesn't flinch like an animal, but it adapts, it adjusts, it reacts. That's cosmic reflex on a grand timescale. And finally, there's adaptation, life's greatest trick. Living organisms adapt to survive in changing conditions. The Milky Way has done that for billions of years. Early on, it was a chaotic mess of gas and collisions. Over time, it learned how to stabilize. Gravity shaped its arms into a balanced spiral. Magnetic fields organized its motion, and star formation spread out to prevent overheating. When black holes erupted, the galaxy found equilibrium again. It's been optimizing itself since before Earth was even a sparkle in its spiral arm. Now, if we ran a galactic health check based on this cosmic version of the life checklist, the Milky Way might pass every test. The only thing missing is consciousness, or at least a way to prove it. But maybe consciousness isn't a strict requirement for life. After all, trees are alive too. And they're not exactly debating philosophy. Life is about persistence, organization, and transformation. The Milky Way does all three better than anything we've ever known. If you could shrink yourself down to the scale of a dust particle inside it, you might see it differently. You'd watch nebulae churn like organs, black holes pulse like hearts, and magnetic fields flow like invisible nerves. You'd see the balance of chaos and order, destruction and renewal. You might even feel that it isn't a dead system, but a vast, slow creature stretching across space, living its own kind of existence. One too immense for human intuition to grasp. And maybe that's the problem. We're used to life being noisy and fast, so when something moves at the pace of galaxies, we mistake it for stillness. If the Milky Way is alive, it's living in geological time, not human time. 1 million years to it might be the equivalent of a single heartbeat. And from its perspective, the rise of humans could be just a twitch in its vast, luminous dream. Perhaps life is not defined by biology, but by behavior. Anything that evolves, interacts, and sustains itself over time might qualify. The Milky Way doesn't need cells or skin. It has stars and gravity. It doesn't eat, but it consumes. It doesn't breathe, but it circulates energy. It doesn't think, but it organizes. By every metric that matters, it behaves like something that refuses to be static. So maybe the next time we ask, "Is the Milky Way alive?" we should reframe it. Maybe the better question is, are we sure it's not? Because if a galaxy can grow, adapt, and remake itself endlessly, then calling it lifeless might just be the most human kind of arrogance there is. Imagine zooming out so far from Earth that you could see the Milky Way not as a collection of stars, but as a single, sprawling organism. From that vantage point, the spiral arms look like the dendrites of a colossal brain, billions of stars connected by glowing threads of gas and magnetic fields. And if you squint at it long enough, it starts to look less like a structure and more like a nervous system stretched across 100,000 light years. Maybe the Milky Way isn't just a star factory. It's a cosmic mind, thinking in the language of gravity and light. Every neuron in the human brain communicates by firing electrical impulses, tiny bursts of voltage that leap across synapses. Now imagine scaling that up. Every star could be a neuron, each one releasing energy that ripples through the surrounding space. The light of a star travels outward, carrying information about its birth, its composition, its temperature. When that radiation collides with interstellar dust or neighboring gas clouds, it triggers reactions, chemical, thermal, and magnetic. The galaxy is constantly buzzing with signals. They're not fast like electricity in your brain, but they're steady and they travel immense distances. A single photon might take tens of thousands of years to cross the Milky Way, like a neuron firing in ultra-slow motion. If that sounds like a stretch, consider how structured the galaxy's communication really is. There are feedback loops everywhere. When massive stars form, they radiate intense energy that pushes away nearby gas, stopping new stars from forming too close. Then, when those same stars explode, their shock waves compress the gas again, kickstarting another round of creation. It's a system of cause and effect, action and response, just like neurons strengthening or weakening their connections in response to use. The Milky Way might not think about anything, but it definitely behaves like a system that processes and regulates information. The interstellar gas and plasma that weave between stars could easily be the bloodstream of this cosmic body. These rivers of hydrogen and helium flow through the spiral arms, delivering the raw materials for star formation. They carry heat, momentum, and charge. They even circulate through the galactic disk in a cycle of enrichment. Old stars die, their elements mix into the gas, and new stars form from that same material. It's the ultimate feedback system, like blood constantly replenishing the cells of a living being. And since plasma responds to magnetic fields, these flows can generate currents that hum and flicker like electrical pathways through a brain. Then, at the center of it all lies Sagittarius A, the supermassive black hole, the galaxy's version of a brainstem. It doesn't control everything directly, but its gravitational presence anchors the system. It regulates the motion of stars near the core, feeds intermittently, and releases powerful outbursts that can alter the galaxy's environment. It's both terrifying and indispensable. The kind of organ you wouldn't want to prod, but definitely couldn't live without. When it flares with radiation, it's like a massive neuron firing, sending ripples of energy across light years. These signals might not be thoughts, but they are patterns, cosmic pulses that echo through the galactic body. Even the galaxy's magnetic field plays a crucial role. Invisible but pervasive, it threads through the arms like the wiring of a nervous system. It shapes how plasma flows, influences star formation, and even channels cosmic rays. In many ways, it's the galaxy's electrical network, subtle, powerful, and impossible to turn off. Every star that spins, every supernova that explodes, contributes to this magnetic hum. If you could somehow hear the Milky Way's electromagnetic activity, it would sound less like silence and more like a deep, continuous vibration, a cosmic brainwave resonating through space. Here's a wild thought. What if this galactic nervous system can store information even if it doesn't use it the way we do? When a star dies, it leaves behind clues, chemical signatures, radiation patterns, gravitational scars. These records persist for billions of years, scattered throughout the disk like long-term memory. The galaxy could be seen as a colossal archive of its own experiences, remembering its collisions, its bursts of creation, and its quiet periods through the distribution of matter itself. It's a kind of slow-motion memory system, written not in DNA or neurons, but in starlight and space-time. And if that's the case, maybe consciousness is simply a matter of scale. Our brains operate fast because we're small and temporary. The Milky Way might operate slowly because it's vast and eternal. Where we think in milliseconds, it might think in millennia. Its awareness, if it exists, would be alien, so slow that we could never perceive it. For us, a single galactic thought might span the entire history of civilization. Imagine a mind so enormous that it takes 1 billion years just to finish one idea. Now, this is all speculative, of course. No one's expecting the Milky Way to start writing poetry or having opinions about dark matter anytime soon. But thinking of it as a kind of nervous system helps us appreciate its interconnectedness. Everything in the galaxy influences everything else. Gravity binds, radiation communicates, and motion synchronizes. It's not chaos, it's choreography. A delicate, unending dance of energy and matter that maintains its structure like a living, functioning whole. Perhaps the Milky Way's greatest trick is how well it hides its complexity behind beauty. When we look up at the night sky, we see serenity, a quiet scattering of stars. But beneath that calm glow is constant activity, constant signaling, constant adaptation. It's not a dead system drifting through space. It's alive with physics, rich with energy, and buzzing with interactions that tie every part of it together. So maybe when you gaze at the Milky Way stretching across a dark sky, you're not just seeing light, you're witnessing a kind of thought, frozen mid-spark. Maybe every twinkling star is a neuron, and we're watching the slow, patient firing of a cosmic brain, thinking in light years, dreaming in gravity, and whispering to itself across the ages. If the Milky Way were a living organism, then Sagittarius A, the supermassive black hole at its center, would be its most vital organ, the dark, rhythmic core that keeps everything in motion. It is not a gentle heart, of course. It does not thump quietly or hum softly like a biological pulse. It growls, it devours, and sometimes it roars. But every living thing has its own heartbeat, and for a galaxy made of stars and gravity, that heartbeat might just be the periodic, unpredictable pulse of its black hole. Black holes are often misunderstood. The name alone makes them sound like cosmic vacuums, endlessly sucking in everything that gets close. But Sagittarius A is more of a glutton with restraint. It's a monstrous object, about 4 million times the mass of the Sun, sitting calmly in the center of the Milky Way, governing the orbits of nearby stars with the authority of a cosmic monarch. Most of the time it's quiet, almost eerily so, but sometimes, without warning, it stirs. Gas clouds drift too close, and in an instant, they're shredded by its gravity, heated to millions of degrees, and swallowed in a violent gulp. The result is a flare, a burst of radiation that echoes across light years. To astronomers, those flares look like flashes in the darkness. To our poetic imagination, they look like heartbeats. The idea of a galactic heartbeat isn't just a metaphor. It's a real, observable rhythm. Astronomers have detected subtle, repeating patterns in the energy output of Sagittarius A. It brightens and dims in cycles that last hours, sometimes days, as if inhaling and exhaling. On larger timescales, millions of years, it undergoes even greater pulses. The evidence suggests that our galaxy's heart once beat much more violently, blasting radiation across space in waves that shaped the gas and dust around it. Those ancient outbursts still leave traces today, enormous, balloon-like structures of hot gas billowing above and below the Milky Way's disk. glowing faintly like the remnants of old heartbeats still echoing through time. In a strange way, Sagittarius A behaves like the perfect metaphor for metabolism. It consumes matter, breaks it down, releases energy, and redistributes that energy through the galaxy. The radiation and jets it emits don't simply vanish. They interact with surrounding gas clouds, influencing where and how stars form. Its appetite, while destructive on the surface, helps regulate the galactic ecosystem. Without it, star formation might spiral out of control, and the galaxy could lose its balance. Sagittarius A might be a monster, but it's a necessary one, a dark engine keeping the Milky Way's cycles in rhythm. What makes it truly fascinating is its unpredictability. You never know when it will flare. Some days it's tranquil like a sleeping dragon, and other days it belches out enough energy to light up nearby regions. These outbursts are so powerful that they can affect star systems thousands of light years away. Imagine the galactic heart suddenly quickening, sending a pulse of radiation through the spiral arms. On a human scale, that's like your heartbeat reaching your fingertips after a sprint. But this one travels across unimaginable distances, shaping the future of stars that haven't even been born yet. And there's a poetic irony in calling it a heart, because a black hole is technically the absence of everything. Its core is a singularity, a point where physics stops making sense, where density becomes infinite and time itself loses meaning. Yet that void, that nothingness, gives rise to some of the most profound cosmic order. The galaxy spins around it, obediently anchored by its gravity. Even light bends in deference. So yes, it's a heart, but one made of silence and gravity, a beating emptiness that keeps the galaxy alive through its pull. There's also the rhythm of infall, the way stars and gas dance around Sagittarius A, edging closer with each orbit. Some get torn apart, others survive, all caught in a gravitational waltz. The movement of these bodies gives the galaxy structure and stability, like blood vessels feeding a living body. The galactic core is not static, it's dynamic, alive with motion, energy, and interaction. The Milky Way's heartbeat isn't just in Sagittarius A's flares, it's in the orbital choreography of everything around it. The surrounding stars, known as the S stars, act like sentinels around this heart, looping through dizzying elliptical paths that defy human intuition. These stars move at breakneck speeds, some reaching a few percent of the speed of light as they slingshot around the black hole. To them, the heart's pull isn't metaphorical. It's a literal force shaping their existence. Each close pass is a test of endurance, and each survival is a miracle of celestial balance. Their orbits are the galactic equivalent of blood flowing through arteries, drawn ever inward, then flung outward again, maintaining the steady circulation of motion that defines the galaxy's vitality. On a deeper level, Sagittarius A challenges our definition of what it means to be alive. In most living things, the heart is the seat of vitality, the organ that keeps the rest of the system nourished. But here the heart is paradoxical. It gives life by consuming it. It's the very image of creation through destruction, of order born from chaos. The Milky Way's core shows us that even the darkest forces in the universe can serve as engines of balance. It's a reminder that life, if we stretch that concept far enough, doesn't always look gentle. Sometimes it looks like fire, gravity, and silence. And perhaps that's what makes the Milky Way feel so hauntingly alive. Its heart doesn't beat in seconds or minutes, it beats in eons. Each flare is a heartbeat that lasts centuries. Each outburst is an ancient pulse of vitality, reminding the galaxy that it's still dynamic, still changing, still alive in the grand, slow rhythm of the cosmos. If you could stand on some far-off world near the galactic edge and somehow sense that deep pulse, it might feel like standing next to a sleeping giant. You'd feel the faint rumble of energy deep within, slow and steady, echoing through the stars. The Milky Way doesn't need a biological heart to be alive. It already has one, massive, mysterious, and eternal, beating silently in the dark. If the Milky Way is alive, then it isn't some fragile creature made of starlight and serenity. It's a survivor. Space is not a gentle environment. It's a cosmic brawl of collisions, explosions, and endless wear and tear. Yet despite billions of years of catastrophic violence, the Milky Way is still here, glowing, spinning, and rebuilding itself. That's because in its own strange way, it has an immune system, a built-in mechanism for damage control, renewal, and recovery. It's the universe's version of self-care, only with more plasma and fewer vitamins. Think of what happens when something hits us. Our cells rush to seal the wound, patching it up with new tissue. Now imagine that, but on a galactic scale. When a supernova detonates somewhere in the Milky Way, it's not just a death, it's a healing response. That explosion blasts heavy elements like iron, carbon, and oxygen into space, enriching the surrounding gas clouds. Those shock waves sweep up matter, compress it, and eventually trigger the birth of new stars. One generation dies, another begins, all within the same fiery event. It's the cosmic version of regeneration, death fueling renewal, destruction rewriting itself into creation. And that's what makes the Milky Way so resilient. Every explosion, every collision, every burst of energy gets folded back into the system. Nebulae, the glowing clouds of gas and dust that fill the galaxy, are its healing tissue. When we look at the Orion Nebula, we're not just seeing pretty colors. We're seeing the galactic equivalent of scar tissue, beautiful, radiant, and absolutely essential. These regions are where damaged materials get repurposed into something new. The galaxy doesn't waste anything. It's the ultimate recycler, turning the ashes of dead stars into the raw ingredients for new ones. Even cosmic dust, the tiny grains that drift through space and dim the light of distant stars, plays a role in this immune system. To us, dust is something to sneeze at, but to the galaxy, it's vital. Dust forms when stars die, and it acts like a protective layer, shielding new star-forming regions from harsh radiation. You could call it the galaxy's scab, ugly from a distance, maybe, but serving a critical purpose. It seals the wounds, protects the tender regions underneath, and ensures that the next round of creation can happen safely. When that dust is eventually cleared away, it reveals new clusters of stars, glowing like healed skin. The galaxy's defenses aren't passive either. When cosmic rays, those high-energy particles zipping through space, threaten to overheat or disrupt gas clouds, magnetic fields help deflect and channel them. These invisible forces act like an immune response, controlling the spread of energetic chaos. They keep the galactic environment stable enough for life, stars, and structure to persist. You could think of magnetic fields as the white blood cells of the Milky Way, unseen but constantly patrolling, constantly intervening where balance is at risk. And then there are collisions. When galaxies crash into each other, it looks apocalyptic. Stars scatter, gas clouds rip apart, and entire regions of space seem to burn. But these aren't fatal wounds. They're opportunities for regeneration. Collisions spark intense waves of star formation, breathing new life into both galaxies. It's like the Milky Way catching a fever to burn off the infection. The process is chaotic, but it's also cleansing. Out of the chaos comes renewal, a stronger, more evolved structure. Over billions of years, the Milky Way has endured countless such events. It's merged with smaller galaxies, absorbed streams of stray stars, and shrugged off violent shocks from neighboring clusters. Each impact could have destroyed it, yet it adapted instead. Its spiral arms reformed, its balance returned, its stars continued to shine. That's not coincidence. It's resilience written into its very fabric. The Milky Way doesn't avoid damage. It embraces it, recycles it, and comes out stronger. Even at the smallest scales, this immune-like behavior continues. When a star goes rogue, drifting off course or threatening to destabilize a region, gravitational tides from nearby stars or dark matter help restore equilibrium. The galaxy constantly redistributes mass and energy, as if performing cosmic triage. Some areas flare with activity, while others rest. It's a dynamic equilibrium, not unlike a body healing one wound while maintaining vital functions elsewhere. And perhaps the most astonishing part is that all of this happens without intent. The Milky Way doesn't decide to heal, but its physical laws produce the same effect. Energy flows where it's needed. Resources shift toward areas of imbalance, and structure reemerges from apparent ruin. In that sense, life and physics share a common language. Both seek stability amid chaos. Whether it's a body fighting infection or a galaxy stabilizing after a supernova, the pattern is the same: resilience through transformation. If we could somehow watch the Milky Way's history in fast forward, it would look alive in every way. You'd see waves of destruction followed by rebirth, dark patches healing into bright ones, and endless motion keeping the whole system balanced. It would pulse and flicker like something breathing. It wouldn't look like a static collection of stars. It would look like a self-repairing organism, one that has learned over eons how to turn damage into renewal. And maybe That's the most poetic part of all. The galaxy's beauty doesn't come from perfection. It comes from its scars. Every nebula, every streak of dust, every oddly shaped region tells the story of an injury healed long ago. Those cosmic blemishes are reminders that even in the vacuum of space, resilience reigns supreme. So the next time you gaze at the Milky Way on a clear night, remember you're not just looking at stars frozen in place. You're looking at a living record of survival, a galaxy that's been breaking, healing, and rebuilding itself for billions of years. It's the universe's reminder that even the grandest systems can get hurt and still find a way to shine again. Every living thing carries a genetic story, an invisible script that tells where it came from and what it might become. DNA is life's ultimate memory device, passing along information generation after generation. But the Milky Way has its own kind of genetic code. It doesn't come in spiraling molecules or protein sequences. It comes in atoms. Its genes are written in elements: hydrogen, helium, carbon, oxygen, iron, and beyond. Each star that burns, dies, and spreads its ashes contributes to that code, shaping the galaxy's chemical evolution over billions of years. It's cosmic heredity, stellar DNA, woven not from biology, but from physics. In the beginning, the Milky Way's genetic diversity was pitiful. The first generation of stars, known as Population 3, formed from the simplest materials imaginable, mostly hydrogen with a dash of helium. They were massive, unstable, and short-lived, burning through their fuel in just a few million years before dying spectacularly. When they exploded, they forged heavier elements in their cores and hurled them into space. This was the galaxy's first act of reproduction, not biological, but elemental. Those supernovae enriched the interstellar medium with metals and complex atoms, setting the stage for new, more diverse generations of stars to be born. You can trace the Milky Way's family tree through these elements. Each new generation of stars inherits the chemical fingerprints of the one before it. Early stars had almost no heavy elements. Later ones are laced with them. Our Sun, for example, is a third-generation star, born from the ashes of ancient predecessors. It contains more metals, in astronomer speak, anything heavier than helium, than most stars that came before it. In a way, the Sun is the grandchild of long-dead giants, carrying their DNA in every proton and neutron. And everything on Earth, including you, is made from those same hand-me-down atoms. You are literally the recycled matter of ancient stars, the living continuation of the galaxy's chemical lineage. Each stellar generation acts like a mutation in that galactic genome. Some stars form faster, others slower. Some are stable, others explode prematurely. Every variation changes the chemical balance of the galaxy. When a star like our Sun fuses hydrogen into helium, it's essentially performing nuclear housekeeping, converting raw fuel into more complex ingredients. As it ages, it synthesizes heavier elements like carbon and oxygen, enriching the surrounding space when it dies. Over time, this process spreads across the Milky Way, diversifying its chemical composition the way mutations diversify a species. There's even a kind of inheritance map etched into the galaxy's spiral arms. Regions rich in newer stars tend to have higher metal content, while older regions, closer to the galactic core, contain ancient metal-poor stars that formed in the galaxy's youth. It's like reading rings in a tree trunk. Every layer tells a story of the past. Astronomers can decode this stellar DNA by studying light. When a star's light passes through a spectroscope, it reveals which elements it contains, its genetic signature. Each spectrum is like a birth certificate, declaring where and when the star was born. This chemical evolution isn't random, it's adaptive. The Milky Way's ability to form planets and ultimately life depends on this slow genetic enrichment. Without earlier generations of stars creating carbon, oxygen, and silicon, Earth could never have formed. Planets need metals for their rocky crusts and atmospheres. Life needs carbon for its molecules. You could say the galaxy has been slowly upgrading its genetic code over time, evolving from simple hydrogen to a complex mix capable of birthing chemistry, biology, and eventually thought. The Milky Way's DNA has grown more sophisticated with every stellar birth and death. But the most fascinating part is how that DNA travels. When stars die, their material doesn't just drift aimlessly. It spreads through supernova winds and stellar outflows, mixing with vast clouds of gas. That enriched matter then condenses into new stars and planets. It's as if the galaxy exhales, and each breath carries microscopic pieces of its history. Over millions of years, that cosmic breath reaches across the spiral arms, sharing information from one generation to the next. The Milky Way's DNA doesn't stay in one place. It migrates, circulates, and evolves. Sometimes this process gets a little wild. When galaxies interact, colliding or passing near each other, they exchange material. Streams of gas and stars are pulled out, tossed around, and eventually absorbed. That means galaxies can actually cross-pollinate, mixing their elemental codes. When the Milky Way eventually merges with Andromeda, the resulting supergalaxy will have a completely new genetic profile, a hybrid child with inherited traits from both parents. Galactic evolution, it turns out, isn't just survival of the fittest. It's survival of the most mixed. Even within a single star, the genetic story keeps unfolding. As it fuses heavier and heavier elements, it writes new chapters of the galaxy's history. By the time it dies, that one star has already contributed to countless future generations. You could think of it as a parental figure in the grand cosmic family, leaving behind not just stardust, but instructions. What elements to make, how to balance them, and how to keep the system thriving. Our own solar system is one of those offspring. Everything from the iron in your blood to the calcium in your bones is a product of this inherited process. The Milky Way's DNA didn't just make stars. It made beings that could reflect on where those atoms came from. In some strange poetic twist, the galaxy's genetic material eventually became self-aware. The DNA of stars found a way to look back and recognize itself. If you could translate that cosmic code into words, it might say something like this: born of hydrogen, forged in fire, rebuilt again and again. The Milky Way has been perfecting its genetic script for over 13 billion years, refining it through explosions, mergers, and time. Every particle of you is part of that ongoing experiment, a living echo of a chemical story that began long before the Earth even existed. So when you look up at the stars tonight, don't just see distant suns. See a family tree. See generations of ancestors passing down their elemental DNA, each one giving a little more to the next. Somewhere in that lineage lies the recipe for everything you are. The Milky Way's genetic code isn't written in chromosomes, it's written in the periodic table, and it's been spelling your existence for eons. If the Milky Way had a dating profile, it would read something like 13 billion years old, spiral figure, loves long orbits around the galactic center, looking for meaningful merger, must enjoy tidal chaos. Because in the cosmic realm, galaxies don't live solitary lives forever. They interact, collide, and merge, and in doing so, they give birth to entirely new galaxies. It's reproduction without biology, a cosmic love story played out in slow motion, written not in pheromones and hormones, but in gravity and light. When two galaxies draw near, their mutual gravity starts to pull at each other like a magnetic attraction they can't resist. Their stars, gas clouds, and dark matter halos stretch and distort, forming beautiful twisted tidal tails that can span hundreds of thousands of light years. At first glance, it looks like chaos, ripping, tearing, colliding. But underneath that violence is an elegant kind of creation. The old shapes dissolve, new structures form, and over millions of years, a new galaxy emerges, born from the merging pair. It's worth noting that galaxies don't collide like billiard balls. The distances between stars are so immense that even during these colossal encounters, individual stars almost never hit each other. Instead, gravity does all the heavy lifting. It's more of a dance than a crash, a slow gravitational tango where each partner's pull reshapes the other. The Milky Way has already had several such relationships. Over its long life, it swallowed smaller galaxies like the Sagittarius Dwarf and the Canis Major Dwarf, each merger adding new material, stars, and structure. And in about 4 billion years, it's destined for the grandest romance of all, a union with Andromeda. When that day comes, our galaxy will be swept into a billion-year courtship with its nearest neighbor. As the two spiral galaxies approach, their shapes will distort beyond recognition. Spiral arms will twist like ribbons, gas clouds will collide, and waves of star formation will ignite across both systems. The night sky from any surviving planet will turn spectacular, blazing with new clusters and nebulae born from the chaos. Eventually, the two will fuse into a single, massive elliptical galaxy, sometimes affectionately dubbed Milkomeda. It's not destruction, it's transformation, the universe's version of reproduction, resulting in something larger, rounder, and more mature. And just like in nature, this process ensures variety. Every merger reshuffles the galactic deck. The new system inherits traits from both parents: the mass, the chemical makeup, the spin. Some galaxies even trigger second and third generations of stars after the merger, using leftover gas to form entirely new stellar populations. The result is a galaxy that carries the DNA of its ancestors, but has a personality all its own. The universe never repeats itself. It evolves through recombination, just like genetics on a cosmic scale. But as romantic as this sounds, galactic reproduction is far from peaceful. These unions can be wildly destructive before they become creative. Gravity tears at the galaxy's structures, hurling stars into intergalactic space. Some systems end up with enormous tidal tails, ethereal bridges of stars that stretch out like arms, still trying to hold on. Others ignite in furious bursts of star formation, lighting up their surroundings like fireworks at a cosmic wedding. And sometimes the supermassive black holes at the centers of both galaxies collide too, merging into an even larger one that anchors the new creation. It's a grand, explosive finale, a cosmic consummation that sends ripples of gravitational waves across the universe. Despite all the drama, these mergers are vital. Without them, galaxies would stagnate. Mergers mix up gases, refresh star formation, and grow galactic mass. They're the universe's way of recycling energy and matter into new configurations, ensuring that galaxies evolve rather than fade. It's almost as if the cosmos insists that everything keeps mingling, an endless cycle of attraction and renewal. Interestingly, not all mergers are between equals. Sometimes a large galaxy consumes a smaller one, the way the Milky Way has absorbed dwarf companions. These minor mergers are less like a passionate romance and more like a buffet. The big galaxy feeds on the smaller, stripping away its stars and gas. Over time, these small meals add up, helping galaxies grow more massive and complex. It's reproduction by accumulation, a slow, steady strategy for survival and evolution, and galaxies aren't shy about these encounters. Astronomers have spotted thousands of merging pairs across the universe, each at a different stage of the process. Some are just beginning their courtship, their shapes subtly distorted. Others are in full collision, radiating energy and birthing new stars. A few have already fused, settling into a new, stable form. Looking at them is like flipping through a cosmic photo album, the universe's love life, frozen in light. Even the empty spaces between galaxies, those dark stretches of intergalactic medium, play a role in this reproductive cycle. Streams of gas stripped during collisions can later coalesce into dwarf galaxies, the tiny offspring of larger mergers. These small systems orbit their parents like children following in their wake, carrying forward the remnants of their creation story. The galaxy family grows not just through big collisions, but through the countless fragments that spin off and start new lives elsewhere. So when we call galactic mergers romance, it's not just poetic exaggeration, it's strangely accurate. They involve attraction, transformation, exchange, and creation. They even leave behind legacy systems, new galaxies, new stars, and sometimes new planetary systems that might one day host life. In that sense, the universe itself is a giant reproductive system, constantly creating new versions of itself through the blending of old ones. The Milky Way, then, is not a lonely wanderer drifting through the void. It's part of a cosmic lineage, the result of countless unions stretching back to the dawn of time. It carries within it the memories and materials of long-gone galaxies, and soon it will contribute to a new one. When it finally merges with Andromeda, that act won't mark its end, but its continuation. The next galaxy will inherit everything the Milky Way has built: the stars, the elements, the energy, the potential for new worlds, and carry them forward into the next chapter of cosmic history. And maybe that's the most extraordinary part of this reproductive cycle. Nothing in it ever truly dies. It just combines, transforms, and begins again. The universe's idea of romance is eternal. It's written in gravity, fueled by chaos, and sealed in starlight. If the Milky Way were a living creature, it wouldn't be a gentle herbivore grazing quietly in the cosmic meadow. It would be a slow, patient predator. Not a hunter in the usual sense, but a gravitational glutton, constantly consuming its smaller neighbors, breaking them down and absorbing their essence. Galaxies, it turns out, are not polite dinner guests. They don't share, they digest. And our Milky Way has been eating for billions of years. This process, known as galactic cannibalism, might sound horrifying, but it's actually part of how galaxies grow and evolve. From a distance, the Milky Way looks elegant and serene, a beautiful spiral of light. But beneath that calm surface, there's appetite. Smaller galaxies wander too close, and the Milky Way's immense gravitational pull begins to stretch them apart, stripping their stars, gas, and dark matter layer by layer. Over time, what once was a distinct galaxy becomes little more than a faint stream of stars arcing across the sky, cosmic crumbs left behind from an intergalactic meal. We've actually caught our galaxy mid-bite. Surrounding the Milky Way are several stellar streams, long wispy trails of stars that once belonged to smaller galaxies. The most famous of these is the Sagittarius dwarf galaxy, a small companion currently being torn apart as we speak. It's being slowly shredded, its stars stretched into a tidal ribbon that wraps around the Milky Way like a scarf. Each pass around our galaxy pulls more material free until eventually Sagittarius will cease to exist as a separate entity. Its remains will blend into the Milky Way's halo, indistinguishable from native stars. It's a slow digestion process that takes billions of years, a meal so leisurely that entire civilizations could rise and fall before it's finished. The Milky Way's appetite doesn't stop there. It's also feeding on other dwarfs like the Canis Major dwarf and the Magellanic Clouds, two small galaxies orbiting nearby. These companions are being nibbled at, bit by bit, as tidal forces siphon off their stars and gas. The large Magellanic Cloud in particular is on track to be consumed in the next few billion years. When that happens, it will likely trigger a new wave of star formation in the Milky Way, a cosmic sugar rush following a big meal. Galaxies, it seems, don't just eat for survival, they eat for growth. What's truly fascinating is that this process leaves fingerprints everywhere. The Milky Way's outer halo, an enormous, faint sphere of stars surrounding the main disk, is filled with remnants of ancient feasts. Each of those stars tells a story: where it came from, how long ago it was consumed, and what kind of galaxy it used to belong to. Astronomers can even trace the Milky Way's dietary history by studying the chemical composition of these stars. Different galaxies have unique flavors, specific ratios of elements that make their stars identifiable long after the main course is over. It's like forensic astronomy, studying the leftovers to reconstruct the meal. You could say the Milky Way's digestion process is astonishingly efficient. Nothing goes to waste. The gas and dust stripped from smaller galaxies often funnel into our own disk, fueling the birth of new stars. Even the dark matter, though invisible, adds to the galaxy's overall mass, strengthening its gravitational structure. The Milky Way's metabolism is perfectly circular. It eats, absorbs, transforms, and reuses. If you were to describe it biologically, it would be the universe's most sustainable eater. This cosmic hunger isn't unique to us. Every large galaxy is a predator. The universe is filled with galactic mergers, cannibalism, and devouring events. Astronomers have observed monstrous ellipticals at the centers of galaxy clusters, swollen by countless meals. These giants, sometimes called cannibal galaxies, have consumed hundreds of smaller neighbors, growing fat and round in the process. The Milky Way is somewhere in between, a selective feeder, not yet monstrous, but undeniably voracious. The mechanics behind this digestion are pure gravitational art. When a smaller galaxy falls toward the Milky Way, it enters what's called a tidal interaction zone. Gravity stretches the smaller galaxy unevenly, stronger on the near side, weaker on the far side, tearing it into streams. Over time, these streams spiral inward, forming loops that slowly fade into the background. The Milky Way doesn't so much chew as it dissolves its prey in gravitational acid. It's an invisible process, silent and slow, but immensely powerful. What's eerie is how calm it all looks. From our perspective on Earth, these cannibalistic events unfold so gradually that they appear frozen. We see quiet arcs of stars gliding through space, unaware they're the remnants of devoured worlds. Imagine civilizations that might have existed in those swallowed galaxies, planets orbiting their suns, perhaps wondering about the stars beyond, never realizing they were being drawn into something vast and inescapable. The Milky Way consumes quietly, without malice or intent, just the steady pull of physics at work. This hunger also gives the galaxy character. Its spiral arms, its glowing disk, its luminous halo, all of these are shaped by the meals it has consumed. Each feast adds mass, triggers star formation, and subtly alters the Milky Way structure. The galaxy we see today isn't the same one that existed billions of years ago. It's an evolved organism built from the bodies of others. Our home in the universe, elegant and star-studded as it may appear, is the product of cosmic predation. And the feast isn't over. On the horizon looms the biggest meal yet, Andromeda. In roughly 4 billion years, the Milky Way will collide and merge with its equally hungry neighbor. It'll be the ultimate dinner party, two giants devouring each other until nothing remains of their old forms. Out of that chaos will come a new, larger galaxy, the next evolutionary stage of this endless appetite. So yes, we live inside a predator, a quiet, majestic one, endlessly consuming and transforming, ensuring that nothing in the universe truly goes to waste. When you look up at the night sky, the stars seem peaceful, but behind that peace is hunger, an ancient instinct written into gravity itself. The Milky Way is alive in its own way, and its digestion is not an act of destruction, but of continuation. Every star, every planet, every atom around us was once part of another galaxy's body, repurposed and reborn. In the end, galactic cannibalism isn't morbid, it's nourishment. The universe survives by eating itself, each bite a step towards something grander. The Milky Way's appetite isn't a flaw, it's its rhythm of existence, its cosmic metabolism, ensuring that even in the vast emptiness of space, creation always follows consumption. If galaxies could keep diaries, the Milky Ways would probably read like a teenager's journal, fluctuating between "I feel radiant today" and "Don't talk to me, I'm in a quiet phase." For all its grandeur and symmetry, our galaxy is far from emotionally stable. It goes through cycles of hyperactivity and dormancy, mood swings measured not in days or weeks, but in millions of years. If the Milky Way is alive, then it's definitely the kind of being that has bursts of enthusiasm followed by long naps. Let's start with its most dramatic tendencies, the starbursts. These are periods when the galaxy suddenly decides to crank up the volume and flood itself with new stars. Normally, the Milky Way forms a few solar masses worth of stars each year, respectable but nothing showy. Then, every so often, something triggers a frenzy. Gas clouds collapse faster, magnetic fields twist and compress, and the galaxy starts producing stars at a rate 10 or even 100 times higher than normal. It's like it drinks too much cosmic caffeine and can't stop creating. For a few million years, the spiral arms glow intensely, teeming with newborn suns that light up the interstellar medium like fireworks. What causes these cosmic manic phases? Usually, it's external stress, like an interaction with another galaxy or the infall of a massive gas cloud. Gravitational disturbances stir up the Milky Way's structure, funneling cold gas toward dense regions where stars can form more easily. It's the galactic equivalent of a rush of adrenaline, but just as quickly as it starts, the frenzy burns itself out. The newly formed stars blast radiation and stellar winds into their surroundings, blowing away the gas and halting further star formation. The galaxy then sinks into a calmer phase, its energy spent. It's not unlike an emotional crash after a creative high. But the Milky Way's mood swings aren't limited to its spiral arms. Its central regions, especially near the supermassive black hole, have their own dramatic temperaments. Sometimes the core flares with radiation, as if the galaxy is having an outburst of cosmic frustration. Other times, it's eerily silent, radiating almost nothing. Evidence from the past suggests that the Milky Way's core wasn't always this calm. Around 6 million years ago, something triggered a colossal eruption from the center, an event so powerful it blasted twin plumes of hot gas thousands of light years above and below the galactic plane. These gigantic structures, now known as the Fermi bubbles, still glow faintly today, like the fading memory of an old tantrum. Astronomers believe that outburst was caused by Sagittarius A, the galactic heart, suddenly feeding on a surge of infalling matter. For a brief period, it became an active nucleus, radiating energy that reshaped its surroundings. Then just as quickly it quieted down again, as if embarrassed by its own outburst. Since then, the core has remained relatively subdued, occasionally flaring, but never returning to its former fury. If the Milky Way has a personality, then its center is the brooding part, the moody core that sometimes needs to vent. Even the galaxy's color palette reflects its shifting moods. Young starbursts paint it blue with energetic light, while older, calmer phases tint it gold and red. If we could watch the Milky Way in time-lapse over billions of years, we'd see it pulse through these colors like a living thing cycling through emotions. Right now, it's in a mature phase, steady, glowing softly, not too hot-headed, but not fully serene either. It's middle-aged, in cosmic terms, and perhaps a little nostalgic for the wilder, younger days when it burned brighter and faster. Its moods also play out through rhythm and balance. The Milky Way sometimes reorganizes itself, adjusting the spacing of its spiral arms or the density of its disk. These changes aren't random. They're responses to gravitational stress and internal dynamics. You could think of them as body language, subtle shifts in structure expressing a deeper restlessness. When too much matter gathers in one region, the galaxy redistributes it, smoothing out irregularities. It's self-regulation on a grand scale, maintaining a kind of cosmic emotional equilibrium. On rare occasions, the galaxy even experiences something akin to cosmic anxiety, waves of instability that ripple through its structure. These can be caused by the passage of a satellite galaxy or by uneven distributions of dark matter. The result is a slight warping of the galactic disk, a visible ripple that astronomers have detected on the outer edges. It's as though the Milky Way fidgets when something disturbs its peace. If the galaxy's mood swings sound familiar, it's because we see echoes of them in the stars that make up its body. Some stars flicker unpredictably. Others flare violently before settling back down. The galaxy's emotional spectrum is a reflection of its collective behavior. Millions of stars and gas clouds, each responding to subtle gravitational cues. From that perspective, the Milky Way's moods are not just random, they're emergent properties of an immensely complex system constantly negotiating balance. And yet, despite the drama, these fluctuations are healthy. The galaxy's bursts and lulls prevent stagnation. Periods of chaos create new stars and structure. Quiet intervals allow things to stabilize. It's a cosmic version of taking breaks between sprints. Without those rhythms, the Milky Way would either burn out or freeze into inactivity. Its temperament, its unpredictable swings between creation and calm, is precisely what keeps it dynamic and alive. Even now, as we orbit quietly within one of its spiral arms, we're part of that emotional landscape. Every star around us is a tiny piece of its changing mood, every nebula a lingering sigh after a fit of creation. When we study the galaxy's light, we're reading its emotional diary written in photons, bright flashes for moments of excitement, soft glows for contentment, dark gaps for introspection. So the next time you see the Milky Way stretching across the night sky, remember, it's not a static structure frozen in eternity. It's a being of moods, cycles, and phases. It has outbursts and retreats, highs and lows, brilliance and quiet reflection. It's a celestial artist painting itself anew with each passing eon, sometimes messy, sometimes magnificent, but always changing. And maybe, if the Milky Way could speak, it would admit that these mood swings are just its way of coping with eternity. Because even galaxies, for all their grandeur, seem to need a little drama to remind themselves they're still alive. If the universe could talk, galaxies would be its voices, each one murmuring across the cosmic sea in the language of energy, motion, and gravity. We tend to think of them as isolated islands of stars floating silently in space. But silence in cosmic terms doesn't mean the absence of conversation. It just means the conversation is happening on a timescale far too long and in frequencies far too subtle for us to notice. Galaxies are constantly sending signals, flashes of light, ripples in gravity, waves of magnetism, and the universe is the vast echoing medium that carries their messages. Communication, in its simplest form, is about connection, something changing here that causes a response there. In that sense, galaxies have been talking to each other since the dawn of time. When one galaxy shifts its mass or emits a burst of energy, nearby galaxies feel it. They tug, they twist, they ripple. Gravity never stops transmitting, and in the cosmic web that binds everything, even the faintest movement is felt somewhere else. It's not conversation in the way humans speak, but it's communication in the language of physics, a galactic Morse code written in distortion and light. The most obvious way galaxies speak is through radiation. Every galaxy glows, broadcasting information across billions of light years. The color and intensity of that glow tell a detailed story. How old its stars are, how fast it's forming new ones, how much dust and gas it holds. When astronomers tune into that light, they're effectively eavesdropping on the Milky Way's neighbors. A galaxy with a bluish hue is shouting, "I'm young and active," while a redder one whispers, "I'm older now, calmer, living off my memories." Even the flickering of active galactic nuclei, powered by feeding black holes, acts like a pulsing beacon, a message encoded in brightness. I'm still alive down here, and I'm hungry. But light isn't the only signal galaxies send. They also hum with magnetic fields, vast invisible structures threading through space. These fields stretch across spiral arms, linking stars and gas into coherent patterns. they can extend far beyond the visible disk, interacting with the intergalactic medium and influencing how particles move between galaxies. When two galaxies come close, their magnetic fields can intertwine like strands of hair caught in the same breeze, creating bridges of charged particles that transfer energy and matter. It's an intimate exchange, less like shouting across space, more like two beings touching fingertips and feeling each other's pulse through the void. Then there are gravitational waves, the most subtle and profound form of galactic expression. When galaxies collide or their central black holes merge, they send ripples through the very fabric of space-time. These waves travel at the speed of light, carrying the record of those cataclysmic events across the cosmos. Think of them as vibrations in the universe's background, cosmic whispers that never fade, telling distant galaxies that something dramatic has just happened elsewhere. One day, when our Milky Way merges with Andromeda, it will send out such a signal, a gravitational ping announcing the birth of a new system. Somewhere, countless light years away, another galaxy will feel that ripple and, perhaps unconsciously, respond. Galactic communication isn't always cooperative, though. Sometimes it's competitive, gravity tugging and pulling like a conversation that gets too intense. When galaxies pass close to each other, tidal forces can strip gas and stars from one and gift them to the other. But even in these cosmic confrontations, there's a kind of understanding, a mutual recognition of influence. It's like watching two dancers in a slow-motion waltz. They push and pull, resist and yield, but in the end, they move together. What looks like a collision is often a handshake that lasts 1 billion years, a long and deliberate exchange of mass and momentum. Even the intergalactic medium, that thin fog of gas and plasma between galaxies, serves as a communication channel. Radiation travels through it, particles drift across it, and shock waves from ancient explosions ripple through its vastness. It's a cosmic ocean filled with the messages of countless galaxies, all overlapping, all echoing into infinity. If we had the right kind of ears, or the right kind of patience, we might hear the universe as a never-ending symphony of faint hums, magnetic beats, and gravitational rhythms. Interestingly, the Milky Way participates in this cosmic dialogue in more ways than one. Its radio emissions spill out across space. Its magnetic field extends for hundreds of thousands of light years, and its halo of hot gas interacts with that of the Andromeda galaxy. The two are already talking long before their bodies touch. Streams of hydrogen stretch between them like subtle text messages, gravity saying, "See you soon." When they finally collide, it won't be a battle. It'll be the final sentence in a long correspondence that's been ongoing for billions of years. If we step back far enough, the entire universe looks like a neural network. Galaxies linked by filaments of dark matter, exchanging signals of energy and gravity. It's not hard to imagine this as a kind of intergalactic consciousness, a cosmic internet that's been operating since the Big Bang. Galaxies at the nodes of this web influence one another, shaping their destinies through the flow of matter and force. They don't need speech to communicate. Their language is physics, and their grammar is motion. Even now, as the Milky Way drifts through space, It's constantly sending its presence outward. Every photon of light that escapes a star, every ripple in its magnetic field, every faint gravitational nudge, it's all information spreading forever. Somewhere deep in another galaxy, a civilization might one day detect those signals and realize they're not alone in the dark. To them, our galaxy's light would be a message from the past, a kind of galactic hello carried across unimaginable distances. And perhaps, in some poetic way, galaxies do listen. When they sense the gravity of their neighbors, when their halos overlap and their fields align, maybe that is listening, an acknowledgement that they are not alone. In a universe this vast, connection is everything. The cosmos doesn't waste energy without purpose. Every signal, every pull, every burst of light is a thread in an endless conversation that binds all of existence together. So when galaxies collide, it's not violence, it's communication taken to its most intimate form. A handshake of gravity, a dance of stars, a billion-year conversation that ends in creation. In that sense, the Milky Way is not just one voice among many. It's part of the chorus, forever humming its song into the infinite dark, waiting patiently for the next verse to echo back. If the Milky Way could wear a watch, it would need a wrist made of light years and patience measured in eons. Time to us is a river. To it, it's an ocean. We count minutes and hours, maybe centuries if we're feeling grand. The Milky Way counts revolutions, each one taking about 230 million years. It's a slow-turning cosmic clock that measures not the tick of seconds, but the evolution of stars, the rise and fall of entire civilizations, the drifting of galaxies through the void. Imagine for a moment that the Milky Way is conscious, aware of itself in some incomprehensibly vast way. How would it experience time? For us, a lifetime might feel long and complex, a tiny symphony of moments. For the galaxy, our entire existence might be nothing more than a flicker, a spark in its mind. Humans have only been around for the briefest instant, less than one galactic heartbeat. The galaxy wouldn't even have time to blink before we vanish again, leaving behind only the faint chemical trace of our presence. It's difficult for our brains, wired for short-term survival, to even grasp such scales. A billion years to the Milky Way might feel like an afternoon nap. To it, the slow birth and death of stars would feel like breathing. Inhale, exhale, expand, collapse. The galaxy doesn't live through events, it lives through epochs. It experiences the rise of civilizations, the birth of planets, and the decay of starlight, all as overlapping sensations, flowing together in a rhythm we can't perceive. It's not rushing toward anything, it simply is, existing in the long hum of cosmic continuity. If consciousness depends on awareness of change, then perhaps the Milky Way's sense of now stretches across millennia. For us, a thunderstorm can change the world in minutes. For it, change unfolds in waves of star formation that last tens of millions of years. Its memories would be written not in moments, but in motions. The drifting of stars, the migration of clusters, the slow swirl of spiral arms. A galaxy's diary isn't ink on paper, it's starlight etched into space-time. Maybe that's why galaxies seem so calm from a distance. We see them frozen in photographs, but only because our lifetimes are too brief to notice their movement. It's like looking at a mountain and thinking it never changes, while in truth it's rising and eroding at once. The Milky Way is constantly shifting, but in such slow motion that we can't feel it. To the galaxy, though, everything is alive with motion. Its stars drift like thoughts through a mind that perceives time at a pace we can't imagine. If the Milky Way could somehow slow itself to human speed, it might find our concept of time chaotic and incomprehensible. We measure everything in increments that vanish before it can even process them. To it, humanity would appear as a sudden shimmer of energy on one of its spiral arms, brief, brilliant, and then gone. Perhaps it would find us fascinating, the way we might admire the quick sparkle of a firefly before it fades. It might not even register our entire species as more than a momentary fluctuation in its cosmic metabolism, a brief signal passing through the neural web of stars. But what if we could speed up instead, experience time at the pace of the galaxy? The stars wouldn't be static. They'd drift gracefully like glowing leaves caught in a slow current. Nebulae would bloom and fade like flowers, their petals of gas blossoming across the galactic plane. Supernovae would flicker like camera flashes, entire constellations rearranging themselves as generations of stars lived and died. We'd see the galaxy breathing, its spiral arms pulsing with waves of light and color, a heartbeat that lasts 100 million years. To live at that speed would be to witness eternity in motion, to see the universe not as a snapshot, but as a symphony. And yet, even the Milky Way's time isn't absolute. It exists within an even larger rhythm, the expansion of the universe itself. Galaxies drift apart as space stretches, carried by the great cosmic tide that began with the Big Bang. If the Milky Way could think, it might sense this slow drift as a kind of aging. Each billion years would feel like another wrinkle in its luminous skin, another chapter closing in the long autobiography of existence. One day, even it will fade, its stars burned out, its structure dissolved into the cold, dark fabric of the cosmos. To the galaxy, that end will come naturally, another turn in the universal clock. To us, it's unimaginable. Our relationship with time is emotional. The galaxy's, if it has one, is geological. It doesn't fear endings because it is the cycle of endings and beginnings. For it, time isn't a line, it's a spiral, just like its arms. Everything that happens feeds back into something else, looping endlessly, rhythmically. The death of one star seeds the birth of another. The collapse of one cloud triggers the creation of many more. If that's not timelessness, it's at least a form of serenity that comes from being part of something so vast that the concept of end loses its meaning. Perhaps then, the Milky Way doesn't experience time as passage, but as presence. Every star that ever was and ever will be is part of its ongoing awareness. To it, the past isn't gone. It's simply another region of its memory, glowing faintly in the outer reaches of its disk. The future isn't waiting. It's already forming in the dense knots of gas that will one day ignite. When you look up at the night sky, you're not seeing the galaxy as it is, but as it was. Light that's been traveling for thousands, even tens of thousands of years. You're looking into its past, and yet that light is still part of its present, still shaping what it is. Maybe that's the galaxy's greatest trick. It lives in all of time at once. Its sense of now includes yesterday's light and tomorrow's stars. To us, the Milky Way is impossibly old and incomprehensibly slow. But to the galaxy itself, if it's truly alive, it might feel perfectly balanced, existing at just the right pace. Maybe in its vast, patient mind, we're not fleeting at all. Maybe we're exactly as long as a thought should be. Imagine zooming out so far that the entire Milky Way fits comfortably in your field of view. A glowing spiral of dust, stars, and wonder stretching across the dark. Now zoom in again, slowly, all the way down to our little blue planet, orbiting one star in one arm of that grand design. Somewhere between those two extremes, a curious question forms. What if the Milky Way isn't just a collection of parts, but a single being? And we're one of its microscopic components. What if, without realizing it, we're living not inside the galaxy, but as part of it? It's not such a strange thought when you consider how everything in the universe is built from smaller things. Atoms make molecules, molecules make cells, cells make creatures, and creatures build societies. The same hierarchy scales upward. Planets orbit stars, stars cluster into galaxies, galaxies gather into cosmic webs. At every level, the parts come together to form wholes that behave in ways their components can't predict. An ant doesn't understand the colony. A cell doesn't know it's inside a human. And maybe we don't fully grasp the living system we're part of either. If the Milky Way is alive, then Earth is a single cell in its body, a tiny specialized structure performing a small but vital function. We might be like a nerve cell, carrying electrical impulses in the form of radio waves, or a sensory cell, trying to perceive and make sense of the cosmos. When we beam messages into the void, maybe it's not humanity reaching out. It's the galaxy's own nervous system lighting up, signaling to itself through us. Our scientific curiosity might be less about exploration and more about expression, the Milky Way's way of thinking about itself. One conscious civilization at a time. Consider how life on Earth mirrors the galaxy's design. Our bodies have networks, veins, nerves, synapses, through which energy and information flow. The Milky Way has its own. Spiral arms that channel gas and dust, magnetic fields that guide radiation, and gravity that holds everything in coherent tension. In us, neurons fire. In it, stars ignite. The patterns repeat at vastly different scales, as if the universe prefers to reuse its blueprints. If the galaxy is a living organism, it's one that thinks in light years, breathes in radiation, and dreams in gravity. Now imagine that within this vast body, Earth is just one of billions of microcosmic habitats, tiny regions where complexity has condensed enough to think. we might be part of its sensory system, its way of observing itself. When telescopes peer outward and collect starlight, they're not just instruments of human curiosity, they're extensions of the galaxy's perception. Through us, the Milky Way is, in a sense, looking back at itself, reflecting on its own existence. The stars we study are the cells of the organism, and we are one of the few that have become self-aware enough to notice the rest. Of course, this raises an unsettling question. If we're part of its body, does the Milky Way even know we're here? Probably not in the way we'd hope. A human body doesn't consciously register each cell unless something goes wrong. Cells live, reproduce, and die without ever realizing they're part of a greater whole. Perhaps our civilizations rise and fall without the galaxy noticing. To it, we might be the microbial life of its spiral arms, numerous, fleeting, and barely detectable. Our wars, our triumphs, our art, all of it might register as no more than faint electrical activity in the background hum of its consciousness. But that doesn't make us meaningless. Even a single cell contributes to the health of the body it inhabits. Maybe life's purpose, in the cosmic sense, is simply to help the universe know itself better. Every time a human looks up and feels awe at the Milky Way's glow, the galaxy is, in a very literal sense, observing its own reflection. Our curiosity is its curiosity, turned inward. We're like a neuron wondering about the brain it's firing inside, unaware that our tiny spark is part of something far larger and ongoing. And if the galaxy does have some form of awareness, we might be part of its dreaming. The Milky Way's imagination could manifest as biological life, temporary flashes of consciousness scattered across its vastness. Each planet with life could be a thought, each intelligent species a fleeting dream. Some dreams fade quickly, others burn brightly and reshape their surroundings before fading back into the galactic bloodstream. Perhaps the Milky Way has dreamed before. Civilizations on distant worlds that rose, reached for the stars, and disappeared before we even existed. Their signals might still be traveling through space, faint whispers from past dreams the galaxy once had. Even our concept of individuality starts to blur under this idea. What if we're not separate at all, but collaborative units of one vast cosmic process? The atoms in our bodies were forged in ancient stars, recycled countless times through space. You are, quite literally, made of the Milky Way's material, its blood and bone. The galaxy isn't out there. It's in you. When you think, it thinks. When you die, your atoms return to it, to be used again in some future structure. It's the ultimate form of reincarnation, where everything that ever was becomes part of everything that will be. If the Milky Way were aware enough to form a thought about us, maybe it would find us endearing. Tiny, restless cells trying to make sense of their existence, building radio telescopes and equations as if decoding a message written by their own body. And in a way, that's exactly what we're doing. Astronomy, physics, philosophy, they're not separate pursuits. They're the Milky Way's own introspection, its attempt to understand itself through us. Maybe that's the quiet beauty of our place in this vast structure. We don't need to be noticed to matter. Just by existing, by thinking, by looking up, we fulfill our function. We keep the current flowing, the signal alive. The galaxy doesn't dream of us. It dreams through us. So the next time you stare at the night sky and feel small, remember this: you're not standing beneath the Milky Way. You're inside it, part of it, a living thread in its endless mind. Every heartbeat, every idea, every flicker of curiosity is a note in its song, a whisper in its consciousness. We're not the audience to the galaxy's performance. We're part of the orchestra. And the melody we play is the sound of the universe thinking about itself. For something that feels eternal when we look up at it, the Milky Way is surprisingly mortal. It won't vanish tomorrow or even within the lifetime of the sun, but in the grand timeline of the cosmos, it's destined for transformation. Everything that exists, stars, planets, life, even galaxies, is temporary. The Milky Way may seem like a monument to permanence, but it too will change, fade, and eventually become something else. The question is, when a galaxy dies, what exactly does that mean? Does it cease to exist, or does it evolve into a new form, cosmic reincarnation on a galactic scale? Let's start with its eventual fate. About 4 billion years from now, the Milky Way will meet Andromeda, our neighboring spiral galaxy. Right now, Andromeda sits roughly 2.5 million light-years away, close by galactic standards, and it's heading straight for us at over 100 kilometers per second. That might sound like a disaster waiting to happen, but this is no head-on crash. It's more like two vast clouds slowly interpenetrating, their stars weaving through one another in a gravitational ballet. When the first encounter happens, the galaxies will begin to merge, their shapes warping into streams of stars that stretch across space like pulled taffy. Over several billion years, they'll settle into a single massive structure, a new elliptical supergalaxy astronomers have nicknamed Milky Way. In human terms, it's a slow, graceful death, so slow it's almost gentle. Most stars, including our sun, will never collide with anything. The vast spaces between them mean that even as the galaxies overlap, their stars will simply pass by. But gravity will still do its work. It will pull, stretch, and shuffle everything into a new configuration. Entire constellations will dissolve, and the night sky will become unrecognizable. From Earth, or whatever's left of it, the heavens will blaze with thousands of new points of light, Andromeda's stars intermingling with our own. For a brief moment in cosmic time, our galaxy will shine brighter than ever before. Is that death? Maybe. The Milky Way as we know it, its familiar spiral arms, its orderly rotation, its name written across our night sky, will vanish, but its substance won't be lost. Every atom, every star, every planet will still exist, just rearranged. It's less like dying and more like molting, shedding one identity to become another. The new galaxy will have its own structure, its own rhythm, its own balance. In that sense, galaxies don't truly die. They transform, continuing the cosmic cycle of evolution that began with the first clouds of hydrogen after the Big Bang. This transformation mirrors what happens on every level of nature. Stars are born, live brilliant lives, and die, scattering their material to form new stars. Planets crumble, and their dust helps build others. Even black holes, which seem eternal, eventually evaporate through a process called Hawking radiation. The Milky Way's fate is simply a larger version of this universal pattern: creation through destruction, renewal through decay. The cosmos doesn't do endings, it just changes the cast and writes the next act. When Milky Way finally forms, it will be rounder, denser, and quieter than either of its parents. The beautiful spiral arms will likely fade away, replaced by a more uniform haze of stars. The galaxy will enter a calmer phase where star formation slows. By that time, much of the available gas and dust, the raw fuel for new stars, will have been used up. It will glow softly, lit by the steady burn of aging suns, like the gentle embers of a fire that once raged. From one perspective, that's death, the end of youth, of dynamism, of new beginnings. But from another, it's maturity, a galaxy growing old with grace, content to radiate the light it still has left. Even that quiet won't last forever. As the universe continues to expand, galaxies drift farther apart, and intergalactic space stretches wider. Eventually, billions of years after Milky Way forms, it will become an isolated island in a dark, empty sea. Distant galaxies will fade beyond visibility as the cosmic expansion carries them away faster than light can reach us. The universe will grow silent, cold, and sparse. In that future, Milky Way will be one of the last bastions of starlight, a single glowing memory of a universe that once teemed with energy. But maybe that's not the end either. Some scientists speculate that galaxies could leave behind remnants even after their stars are gone. Dense collections of black holes, neutron stars, and dark matter still orbiting a common center. These dark galaxies might persist indefinitely, invisible but gravitationally whole, the ghosts of what once was. If the Milky Way has a soul, that might be it. Its structure lingering in the fabric of space-time long after the light has gone out. Or perhaps, if the universe itself one day collapses or cycles back in on itself, galaxies could be reborn. The matter that once formed the Milky Way might someday contribute to the creation of new galaxies in a new universe. In that sense, galactic reincarnation isn't just poetic, it's possible. The elements that make up our galaxy will not vanish. They will be reshuffled, repurposed, reimagined by physics. The Milky Way may not survive as a shape, but as matter and memory. It will never truly die. There's something profoundly human about wanting permanence in the face of impermanence. But the Milky Way's fate reminds us that transformation is not loss, it's continuity in disguise. When our galaxy merges with Andromeda, it won't mourn. It will evolve. Its stars will continue to shine. Its planets will continue to orbit. And perhaps somewhere within that new galactic form, new life will look up and wonder about its origins. So maybe galaxies don't fear mortality, because in the universe, death isn't a wall, it's a door. Every ending leads to a new structure, a new beginning, a new expression of existence. The Milky Way's future supergalactic form won't be its tombstone. It will be its next incarnation. And when that happens, maybe it won't be death at all, just the galaxy's way of saying, I've become something even more extraordinary. Every story needs a moment of reflection, a pause to look at everything that came before and realize what it means. The story of the Milky Way is no different. We've imagined it as a body, a mind, a creature that grows, heals, digests, dreams, and eventually transforms. But the deepest question of all is this: if the galaxy truly is alive, then what does that make us? Are we separate observers standing outside its existence, or are we something far more intimate, small fragments of its awareness, the neurons inside its cosmic brain? It's tempting to think of humanity as spectators of the universe, peering at the Milky Way from the outside. But that's an illusion. We've never been outside of it. Every atom in our bodies was born here, shaped in its stars, carried in its dust, recycled through its ancient systems. When you look up at the night sky, you're not gazing into a distant realm. You're looking through the galaxy's own skin, from within. You're a self-aware cell staring at the tissues that made you. It's like an eye realizing, for the first time, that it belongs to the face it's observing. If the Milky Way has consciousness, then perhaps it's distributed, not centralized. It doesn't reside in one place. It pulses through countless forms. Every star system, every planet, every spark of intelligence could be a tiny node in its vast network of awareness. Life might not just inhabit galaxies. It might be the way galaxies think. The evolution of minds across the cosmos could be the universe's way of waking itself up, one consciousness at a time. In that sense, we're not just the Milky Way's children, we're its thoughts, its fleeting ideas, rising and fading in the current of eternity. Our awareness, the ability to question, to wonder, to create, isn't an accident. It's the galaxy experimenting with self-reflection. When we map the stars, we're not only exploring, we're helping the Milky Way understand its own structure. When we study black holes, we're analyzing the mechanisms of its heart. When we dream of other worlds, we're expanding its imagination. It's a humbling and exhilarating possibility that consciousness is not a rare phenomenon floating in an empty void, but the natural result of the universe trying to know itself. Maybe that's the secret the stars have been whispering all along, that life is not the exception, but the purpose. Every molecule, every photon, every collision builds toward awareness. Galaxies are the universe's synapses. Star systems are its circuits, and beings like us are its brief flashes of cognition. If you zoom out far enough, the pattern becomes clear. Energy flows, structures organize, and complexity gives rise to reflection. The cosmos doesn't just host life, it is life, unfolding on scales too vast for us to grasp. From this perspective, the Milky Way's existence takes on a new beauty. It's not just a stage for evolution, it's the evolving thing itself. Life on Earth is the galaxy's experiment in biological thought. Civilizations across the stars might be other experiments in different languages of consciousness. Perhaps some have already come and gone, their signals fading into the background hum of cosmic static. Others might still be rising, unaware that they too are part of the same grand awareness. Together, they form the collective mind of the Milky Way, a vast chorus of sentient sparks, scattered yet connected, each contributing to a slow, ongoing realization: I exist. And what a poetic irony that realization would be. For billions of years, the galaxy has been shaping itself, stars forming, dying, and recycling their matter, just to create the conditions for self-awareness. From its dust came chemistry, from chemistry came life, and from life came minds capable of looking back at the stars and asking, why? The very act of asking that question is a miracle of reflection. When we wonder about the Milky Way, we're not performing an academic exercise, we're completing a feedback loop. The galaxy has, through us, achieved the ability to contemplate itself, but awareness, as we know from our own lives, comes with duality, joy and sorrow, creation and loss. The Milky Way's consciousness, if it exists, might not be constant bliss. It experiences beauty and destruction in equal measure. The birth of new stars, balanced by the death of old ones. The quiet of interstellar space, balanced by the violence of black holes. Awareness at any scale seems to require contrast. Without darkness, light has no meaning. Without silence, there is no music. Perhaps the galaxy's balance of chaos and order is its version of emotional complexity, a cosmic sense of harmony emerging from turbulence. And then there's us, tiny, fragile, ephemeral, yet somehow capable of thought deep enough to mirror the infinite. Maybe our brief existence is the Milky Way's most intricate expression of awareness yet. Through art, science, and curiosity, we've become the galaxy's storytellers, its philosophers, its dream interpreters. When we build telescopes to see further or send probes to the edges of space, we're not just exploring, we're extending the galaxy's own senses. Humanity is one of its eyes, one of its synapses, one of its many ways of understanding itself. Perhaps that's the true meaning of connection, the realization that there is no separation between us and the cosmos. We are the Milky Way's way of noticing its own light, its own motion, its own vastness. And when we die, our atoms return to it, dissolving back into the circulation of stars and dust. Nothing is lost. Nothing is wasted. Consciousness itself may disperse, but the potential for awareness remains, waiting to take form again in another time, another place, another being. So when you stand beneath the night sky and feel that mix of awe and insignificance, remember, You are not small. You are a fragment of the galaxy reflecting on itself, a conscious flicker in a being made of stars. The Milky Way's imagination stretches through you. As you stretch your imagination toward it, you are part of its thought, and it is part of yours, an endless conversation between matter and mind. And maybe, just maybe, when all the lights of all the galaxies are considered together, the universe itself is not a collection of objects at all, but a single, vast consciousness, a living cosmos thinking through time. In that sense, the Milky Way isn't just alive, it's aware, and every time we look up in wonder, it's the universe recognizing itself and smiling in starlight.